Welcome back to my session. I am Anusha of CSE Department, Institute of Aeronautical Engineering. In my videos, I am discussing about the subject programming with objects based on Java. So in the previous session, we have discussed about the use of final keyword, how it can be used to prevent inheritance, how it can be used to create constants, and how it can be used to stop method overriding, the object class and its method, and dynamic binding or the runtime polymorphism. In today's class, we will be discussing about abstract classes, packages, and packages. So what are abstract classes? So as we have seen, abstraction is one principle of object-oriented programming, wherein it hides the implementation details from the user. So the process of hiding the implementation details from the user and only making the functionality visible to the user is abstraction. So the user don't have to bother about how the object is working, but it just have the information on what the object will be doing. So it identifies only the required characteristics of an object by ignoring the irrelevant details. So we can define abstract method. We can define abstract method by making use of the keyword abstract. So abstract method, the type name and the parameter list, or the method name followed by the parameter list ending in the semicolon. So we just declare the method as abstract, and its implementation must be given in the class which is making use of it. Okay, so here if we are defining a method, declaring a method as abstract method, then at that point we will not give any implementation, or the method will not be having any body for that. There won't be any body for that method. So abstraction we can achieve in two ways. One is by abstract classes, and other is interface, by the making use of interface. So abstract classes is partial abstraction, whereas making use of interface is full abstraction. We can provide full abstraction by making use of interface. We make use of abstract classes wherein the superclass will declare the structure without providing the complete implementation of every method. So in the superclass, we will be defining the abstract methods. We will be declaring the abstract methods, and these methods will be inherited by its child class, and those child class has to determine what type of implementation should be given to that particular abstract method. So every whichever method is defined as abstract, it must be implemented in the child class. So the abstract class can be declared by the use of abstract keyword. Any class that contain more than one or more abstract method must also be abstract. That means if any class contains at least one abstract method, then that class also should be declared as abstract. And we cannot create any objects for an abstract class. No objects can be created for an abstract class, and hence it cannot be instantiated by the new operator. You cannot create objects using the new operator of an abstract class. Then you cannot declare abstract constructors or abstract static methods. The abstract class may contain non-abstract methods or concrete methods also. It's not that abstract class will have only abstract methods. They can have methods with body which are called as concrete methods. The abstract method is a method that is declared without an implementation. You don't have any body for that abstract method. A method defined abstract must always be redefined in the subclass, thus making overriding compulsory or either make subclass itself abstract. So if we have any abstract method in the superclass, then the child class which is inheriting that superclass should provide an implementation for that abstract method. Or if we are not giving any implementation, then we have to declare that subclass also abstract. Abstract class can have a parameterized constructor and default constructor and a default constructor. And we can have abstract class without any abstract method. So this allows us to create classes that cannot be instantiated but only inherited. Now let's look into an example of an abstract class. So here again we have the class named shape. Its instance variables x and y. So we have shape. Inside shape there is two. You have instance variables x and y and two methods. Print area. Print area is a abstract method. So here you won't have, inside class you won't give any implementation for it. So in the previous case in method overriding, we have seen that the parent class was given an unnecessary implementation. So if we are using abstract class, if we are using abstract method in that case, then we don't have to give any unnecessary implementation for this method. So we have this method print area, which is defined as abstract inside the parent class shape. Now from shape we are deriving the rectangle class and the circle class and the triangle class. So here inside shape there are two methods print area and we have the print area and non-abstract method. So this print area is an abstract method, so this won't have any implementation. This print area doesn't have any body for it. Whereas this non-abstract method is having some implementation. This non-abstract method is given some implementation. Now, this parent class shape is inherited by rectangle, triangle and circle class. So, since there is an abstract method inside the shape class, we are declaring the shape as abstract. And since it is being extended by the rectangle class, the abstract method print area must be implemented inside the rectangle class. So for the print area, it is providing some implementation. It is providing some implementation for print area inside the rectangle class. So we have area of it is defining area of rectangle, the product of the length and side, product of the sides, right? L into B, right? Now, inside the triangle class, again, since triangle class is extending shape, the abstract method defined inside the shape class has to be provided some implementation. So, it is finding the half BH. It is applying the formula half BH for finding area of the triangle. And inside circle, again, it is extending shape, so that print area has to be implemented inside circle also. So, it is displaying the statement area of the circle is pi r square. So, now this math.pi is a constant which is available inside the math class. It is inside this math class is a static class. So, because of which we can access the members of that math class using the class name itself. That is why we are calling it as math.py instead of creating an object of math class and calling them. So, since math class is a static class, we can make use of the class name itself to invoke the members of that particular class, and we are typecasting it into float. Now we are creating inside the test class abstracts, we are creating the object of rectangle and initializing the contents of rectangle's length and breadth to 10 and 20, and you are calling print area. So when you call print area, this statement will be printed. Area of rectangle is 10 into 20 will be printed, and you get the output. Area of rectangle is 200. Now in the second case, we are creating the triangle object. Its values are initialized to x and y, 30 length and the height and base is set to 30 and 35, and we are calling print area. So when you call print area, it will invoke the print area of the triangle class, and area of triangle is half bh will be, the statement will be coming in the output. Then the third case, we are creating the circle, and we are calling the print area of this our circle after initializing the value of x to 2. And when you inside the circle class, it is calling implementing half bh, pi r square, and you get the values as 12.56. So this is about abstract classes. So abstract classes are those classes which have abstract methods, and the abstract methods are those methods which don't have any implementation inside that, and we will be declaring those methods using the abstract keyword. And you cannot you cannot create any object for the abstract classes. Next, let's look into packages. So I would say packages like folders. So wherein we can segregate the files and our classes of same type into one place. If we want to put all the classes of one type into similar type into one place, we make use of package. So, and also it is for providing naming control. Like we cannot have two classes with the same name inside one package. Similarly, we cannot have two files of the same name inside one folder. So same control is being achieved in packages. So we can, it is a mechanism for partitioning the class namespace into more manageable chunks using packages. It provides a naming and visibility control mechanism, and also it prevents the naming conflicts. It provides control access. It makes searching and locating of classes easy. Searching and locating and uses of classes, interface, enumerations, etc. easier. So these are the main uses of packages. Now, if we define classes inside a package, then those classes cannot be accessed outside that package. Only if the so we are providing a protection also to by putting the classes inside a particular package. You can also define class members that are exposed to other members of the same package. A package provides a mechanism for grouping a variety of similar type of classes, interfaces, and sub-packages. There cannot be two classes with the same name in the same package, but two packages can have the same name. Two packages can have a class with the same name. Now there are two types of packages. One is user-defined package and the other is built-in package. The user-defined package is given by the user. Like it will be made by the user or the programmer, and the built-in package is already defined inside Java, inside the JDK, like the IO package, lang package, etc. So this is the package hierarchy of available in JDK, wherein the topmost is the Java class, and inside Java class you have lot of other classes like langs, utils, AWT, swing, etc. Inside the lang class, inside the lang package we have the system class, string class, and others. Similarly, under util class also you have a lot of classes. For example, you have array list and map class, and inside AWT you have the button class and other classes which is used for GUI programming. So this is the hierarchy of. There are two types of packages in Java. One is the user-defined package, which is given by the programmer, or which is being defined by the user, and we have the built-in package, which is given by the JDK itself. So these built-in packages will be given by the JDK, like the IO package, lang package, util package, etc. So if we look into this figure, this is the hierarchy of packages in Java. So on the topmost level, we have the Java package. Inside the Java package, we have the lang, util, AWT, IO, etc. Then inside the lang package, we have the system class, string class, and others defined. And inside the util package, we have the array list, map, and others. And inside the AWT, we have the classes which is used for GUI programming. When we write any program, the first statement of that source file should be package, that package name. Say for example, if we have one package, say unit 1. So if we are writing the programs related to unit 1 in the package unit 1, then the first statement of that will be package unit 1. Okay. Next. Now, if we want to make use of some packages which is defined inside Java or some user defined package in our course, in our source file, then you have to import that statement into Java. So we'll give import. Say for example, if we are creating we want to make use of IO package, then we have to give java.io.star. So if we are making use of star, then it will import all the classes inside the package IO. And if we want to give any particular package from, say, if we want to derive some particular package, then we have to give java.io. that particular package name. So here so if we take any source file, the first statement of that file will be the package statement. Now this indicates the hierarchy of packages. So if you want to create a hierarchy of package, then you can define first package 1. We have the package 1. Then inside that package, you can have package 2. Inside that package 3. So we can write it as package 1 dot package 2 dot package 3. So this indicates the hierarchy of packages. So if we have if we are inside the AWT package, then we indicate the hierarchy here, java.awt.image. That shows that this package is present. This package, this image class is stored inside the AWT package of Java. Okay, so this indicates that the image class is present inside the AWT package of Java. Okay, so and it is stored. That package will be stored inside this path. It will be present inside this path. Now, so we have this program. So in our program, we have package. The first statement, as I've told you, package 1. So inside JDK, we will be having the package as package 1. And inside package 1, we have two classes, class A. Here also, this class also is present inside package 1. So we have two classes, class A and test package. Okay, we have, let it be like this. We have the package 1 folder or package 1, and inside that we have class A. The class A is having display method, and inside again we have this test package stored inside the package 1. So you have test package and the main method of test. So we have the main, right? So this is how we have the package. So we have inside the package folder, we will have the class A and test package. So inside class A, we have the display method, and it is displaying the statement you are using package A. Now in the same package, we have inside the same package one, we have another class also. So first statement of that file should be, of that source file should be package statement. Now in this package, we are importing the class which is present here. So we want to import the class A of package 1. So we are importing this class into our current source file, right? So to import that, we are using package1.class A. So that means we are importing the class A, this class A which is available inside the package A. So this class A inside this package is being imported to this into this source file. So we are creating an object of class A. Now since we have imported the class A into the test package, we can make use of that class and its method here. So we are making use of it. We are creating an object and you are calling the display method. So when you call the display method, you get this statement in the output which is obtained over here from the display method of class A. So this is how packages work. So when you are creating any source file, the first statement of the source file will be the package statement, which indicates in which package it is present. And if you want to import any class or package which is already defined by the user or which is a built-in package, you use the import statement. How will the Java determine where these packages are stored? So to where the Java runtime should look for the packages. So by default, it will look in the current working directory as the starting point. So there are three ways by which it can determine the class path. So first it will check the current working directory as its starting point. So if your package is in the subdirectory of the current directory, then it will be found. Or you can specify a directory path or paths by using the class path environmental variable, or you can use the class hyphen class path option with Java and JavaC to specify the path of your class. So to indicate the where our class is existing or where our package is residing, we make use of the class path. Now, as I've told you, if we want to make use of any built-in packages which is available in Java, then we can use either built-in packages or user-defined package. Then you can use the import statement. By making use of the import statement, you can bring those classes or the entire package into our source file, into our class. Okay, so this once it is imported, the class name is referred using its name. So the general syntax is import the package name. So if you are making use of this statement, then you are making use of the date class of java.util package. Java from the date class under java.util package. So this is, you are particularly making use of the date class. Now here we are using star. So that indicates that from IO package, we are importing all the classes which is available inside the IO package. Now, instead of making use of import statement, we can use a fully qualified name of the class. We can use the fully qualified name of the class. So here we are, this is by making use of the import statement. So we say import java.util.star, that into our file or source. It will import all the statement it will import all the classes which is available inside the util class. But in our program, we just want to make use of date. So you don't have to import all the statements in it, all the classes inside it. So you can give import java.util.date and make use of it. Or instead of using this, we can skip this import statement and write like this, java.util.date. So this is the fully qualified name of that date class, wherein it represents the higher packages in the hierarchy. So it is making use of the, here we are making use of the fully qualified name of that class. Now, as we have seen, when packages are, when files are stored, when our classes are stored in any packages, they are providing protection, right? So by making use of these access modifiers, we can make use of those classes which is stored in any package into some other class. So if we define any member as private, then that member can be used only within that class. It cannot be used by a subclass. It cannot be used by a subclass present in the same package, or it cannot be used by a subclass present in a different package, nor it can be accessed by any class outside that package. Now, similarly, if no modifier is present, means it is default. So if it is default, then it can be accessed within the class, and it can be accessed within the subclass present in the same package. But it can be accessed by a non-subclass within the package. So a default member can be accessed by the classes which may be a subclass or not, but it is present inside the same package. But the classes outside the package cannot access the default member. Now, if it is protected, it can be accessed within the class, and it can be accessed it can be accessed by subclass which is present inside or outside the package, and it can be accessed by a same package non-subclass also. But it cannot be accessed by a non-subclass which is outside the package. And if that variable is, or that member is public, then it can be accessed anywhere. It can be accessed anywhere. Now let's look into an example of providing access protection. So here we have a package P1. We have the package P1. Inside the package P1, we have the protection class. We have one protection, a class named as protection. So inside protection, we have a default variable n, a private variable, a protected, and a public variable which is set to values 1, 2, 3, and 4. Now, inside the constructor of the protection class, since it is the constructor is of protection class, it can access all the variables including private. So it can display the default, private variable, protected variable, and the public variable. So when you create an object and call this, when you create an object, it will invoke, you will get this output. So that is, so we have this protection class inside package 1. So we already have a protection class with package, we have the package P1 with protection class. Now from protection we are deriving the derived class. So we have the derived class which is obtained from the protection class, which is, they both are inside the derived, they both are inside the protection class. So we have the derived class obtained from the protection, wherein since it is derived class is a subclass of protection, it cannot access its private variable. So but other variables can be accessed. It can access the default, protected, and public, but it cannot access the private variable. That's why I have put it in comment line. If you try to access this private variable, then you will get an error at this statement. Now, since derived class is created from the protection class, and when you create an object of derived class, it will invoke the constructor of the protection as well as the derived. So that is why we get these the output of the protection constructor as well as the derived constructor when you create an object. Next, we have the same package. So we have the package P1. Inside package P1, we have the protection. Then from the protection, we have the derived. And from inside the same package, we have another same package class. So there are three classes inside the P1 package where they are protection, derived and same package. From the protection we have derived another class named as derived, and we have a unconnected or a separate class called as same package. Inside same package we are making use of the protection class. Also. So you're creating the protection class object and trying to access the contents of the protection class. So since it is not a subclass, but they are but it is inside the same package P1. It can access all the members except the private member. So it can access the default member, the protected member, and the public member. So, but it cannot access the private member of the protection class. So you have p.n, which will call the default variable n of protection. p.n pro is calling the protected member of protection class, and here it is calling the public variable of protection class. Okay. Now here we are creating. So here we are now we are creating the object of protection class. So at that point, the constructor of P1 constructor of protection will be invoked, and you get this output, wherein since it is protection which is called, it can access all the variables of that class. Now when you call the when you are creating the object of the derived class, that derived class was obtained from the protection class. The derived class came from the protection class, because of which this derived can access all the members of protection except the private variable. So you can since derived class is derived from the protection, when you create an object of it, it will invoke the constructor of the protection also. So because of which you get these statements and these two set of statements. So here derived, inside the derived class we cannot access. Inside the derived class we cannot access the private member. The private member cannot be accessed inside the derived class. So we are accessing only the default, the protected and public member of protection class. Now in the third case, we are invoking we are creating an object of the same package class, and inside the same package you are creating the object of the protection class. Hence we get the protection class constructor statements, and inside the same package also we cannot access the private member. The private member of protection class cannot be accessed. Only you can access the default, protected and public member. So here so all this protection, derived and same package were present in a single package called P1. So the first statement of our program should be the package P1. So when you create when you make use of packages, and if you have some classes inside one package, only the private member cannot be accessed by the members of the same class. The protected as well as the protected default and public member can be of any class can be accessed by others. Only the private member will be hidden from the other classes. Okay. Now here we are creating another package P2. Inside P2 we have two classes, protection 2 and other package. So inside protection 2 we are making use of the P1 making use of the protection class also. So we have P1. From in that we have the protection. From the protection, the derived class came, and we have same package inside P1. Now we have another package P2, wherein it contains protection 2, class protection 2, and other package, class other package. Okay. So P1 has 3 classes. One is in implementing inheritance, and the other package P2 has 2 standalone packages, but protection 1 is making, again protection 1 is extension of protection 2. That means the protection 2 is inherited from protection. So protection 2 can access even though protection 2 is present in a different package, it can access the default as well as it can access, since it is present in a separate class, it can access the protected variable of the protection class. Only the protected variable and public variable can be accessed by the protection 2, which is present inside package 2, but derived from the protection class. So inside protection 2, you cannot access the default member of a protection class, since protection 2 is extending the protection class. Only the protected and public member of protection class can be used over here. It cannot access the default member nor the private member. Now similarly, we have other package. So inside this other package, even it is making use of the protection class, but it is not inheriting the protection class, and it is also present in outside the package P1. So it can access only the public member of protection class. So it can access only the public member of protection class. So when you create an object of protection 2, the protection 2, it is inherited from a protection. So you will have the constructor of protection also invoked, and since it is present outside the package of protection, it can access only the protected as well as the public member of the protection class. And in the second case, we are creating the object of other package, wherein this other package object also is making use of the protection class. So it will invoke the protection class constructor as well as and using that, the other package can access only the public member of the protection class. So this is how we provide access protection in by making use of packages. So hence, by the use of private, default, protected, and public access specifiers can be used to provide protection protection of the data within the packages. So in today's video, to prepare the slides, I have used the textbook by Herbert Schill, the complete reference of the 9th edition, and also the websites Oracle docs.oracle, the Java tutorial from Oracle, and also the Java tutorial from the Java T point. So in today's class, we have discussed about abstract classes, packages, how we can define, create, and access package, what is the importance of class path, and how what is the use of setting class path, and how we can import packages into a class. So these were the topics discussed today in this video. Thanks for watching my video. We'll continue in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.